So I already made a video on going over the cheat sheet you might make for the mathematical methods exam, but there's obviously the second mathematics you do, specialist mathematics, which again the US A, B, B, C calculus or something like that, physics C, whatever you want, but it's the hardest mathematics, or so-called hardest mathematics. It's mathematics you need to do any sort of engineering or anything in tertiary university in the last year of high school. So again, you get 4 sides of an A4 page, so that's I guess 2 A4 pages double-sided, and this time you are going to see sort of 5 distinct subjects, not just 2 that are in multiple units. You're going to have mathematical proof, complex numbers, vectors, calculus, and functions themselves. So let's sort of go over what you might like to put on these cheat sheets. The first one I think is actually going to be identical to the mathematical methods one, so actually if you wrote this one on a distinct sheet, you could probably recycle this, because again it'll just ask you, we've got this function, what is its derivative, what is its integral, and this time they might add a little bit more complexity because they like to be funny like that. But again, ln, the derivative is 1 over x, trigonometries, you should get a sheet that will give you the trigonometric identities already, but if you don't, then it might be good to write those as well. You've got the 3 differential laws, you've got the product rule, the chain rule, and the quotient rule, and you've just got some general integrals as well. If you can solve for one of those, you can solve for f of x as well, then you're pretty set with that. And same with graphical to sine diagrams, it's always good to know what functions sort of look like and what they would be expressed as on a sine diagram. Once again, with a sine diagram you just have a line, and wherever the function is above the line you put a plus, wherever it's below you put a minus, and once again any other graphs that you sort of want to visualize, like the hyperbolic functions, any functions that you're having trouble with specifically, you can put them there as well. Now the second page I sort of truncated a bit because personally I don't think you need more than a second page, but if you want to expand this over multiple pages, that is totally fine as well. With the proof by induction, if you know how to do induction, you won't really need to write anything. It's just about knowing the steps properly. So I show it works for f of 1, and if it works for f of n, any number, then I want to prove that it works for f of n plus 1. So if it works for 1, then it would work for 1 plus 1, which is 2, it would work for 3, 4, 5, and I can sort of say by proxy it works for every possible number I could put in there, because it always works for the next one on. And I just got to write at the end, since p of 1 works, and if p of n works, p of n plus 1 also works, and we can continuously add to p of 1 and the function p will remain equal to y. And that's pretty much a plug and play thing. That is just, you've got to follow these steps exactly and they'll give you the marks. Then we've got 3D vectors. So unlike 2D vectors, 3D vectors are harder, and also in 3D I guess. And we know the dot product equation, just to write that down. The cross product equation, just to write that down. If you have 2 vectors, assume that the 2 vectors are the first one being x1, y1 and z1, and the second vector being x2, y2 and z2. You can plug and play these. If I have 2 vectors, I can solve for both of those just using these equations here. Obviously I, j and k being the unit vectors in the x, y, and z direction. A lot of it is just very conceptual and visual. So if they sort of give you, a situation, you've got to sort of be able to visualize it in your head. You've got to have those 2 functions or a plane and a vector coming out of it. With the vectors, it's more about figuring out the conceptual and visual idea behind it. Complex numbers aren't that difficult either. You've just got to understand obviously what I is, square root of -1. A plus bi is the way you express it, because we can't really sort of express both of them in a single number, usually denoted by z. The length of z, the modulus of z, is just Pythagoras, the square root of a squared plus b squared. And the argument, which is the angle, because we can express complex numbers as sort of a vector coming out of the center of a Cartesian plane. The argument is just going to be the inverse tan of b over a, and then we could express it as the polar form, which is the modulus of z multiplied by cis of theta, which is the argument. And that can also be expressed in the Euler form, which is the modulus of z multiplied by e to theta, and they're exactly the same. They're exactly translatable, and then you can convert between the Cartesian form a plus bi and this form whenever you want. This is a video about writing a cheat sheet, not a video about how to do that. Inverse functions, f to the -1x from f of x, simply do BEDMAS backwards. It's just like finding x known y. It's just like finding y known x. It's perfectly back and forth. It's just about not getting tripped up with accidentally adding or subtracting or putting a sign in a wrong spot. It's just about double checking your work once you've found the solution. And then integrating volumes. If you've got a function, you can square that function, so square the entire function, and we already established what the square of it looks like. And then you integrate that and you multiply it by 2 pi, and that gets you the volume revolution, because it's like finding the area of a cylinder, but the cylinder's a bit of a strange shape on the outside. And that really covers everything again. And again, these exams aren't meant to be hard, they want you to succeed. And also you will get the helpful sheet with the formula. And if these are the things you should have on that sheet that they give you, and if you know what it's going to be beforehand, it's good to check that all these things are on there. And if not, then you should write them yourself on your cheat sheet, because they will be important. So the trigonometric identities are important, sort of the sum to product formulas, all that kind of stuff. They're good to know. Sine rule, cosine rule, the formula to find a determinant of a matrix, projection vector formula, dot product and cross product for 2D vectors if you haven't memorized those already, Pythagoras equation, who doesn't know the Pythagoras equation, integrals and inverse trigonometric equations are also good. And they're just equations. All of these I've just mentioned, there's no conceptual learning to it. It's literally just read the question, plug and play the known values, find the unknown value, so just add them to your sheet. You can just add them anyway if you want, because I've only given you 2 sheets to fill out, so if you've got those 3rd and 4th sheet, you can write them on there. This exam's a lot less input-output than the mathematical methods. It's a bit more conceptual, but as long as you can logically think about a situation, just work through it. And again, everyone's going to be in the same boat as you, and just take into account each point. They're not going to write something on the exam question as a red herring. Every single thing in that question is going to be relevant, so just get all the pieces that you have and fit the puzzle together.